Welcome to the Layer7 API Security May office hours. I'm Pamela Deesa, Marketing Manager for Layer7. For this month's office hours, I actually have with me two representatives from DCOS. We have Vince Baker and Christian Holm from DCOS who will be presenting. I just wanted to let you know, as usual, you are all on hard mute. So if you do have questions during the presentation, type it in the panel. Be sure to type it in the panel and we'll save some time at the end. At the end, I'll take you off hard mute. You can ask your question directly if you prefer it that way. But for now, I'm going to turn it over to Vince Baker to get us going.
Hello, everyone. It's good to be here. For those of you who haven't met me, yeah, I'm Vince Baker, and I'm joined today by my good friend and colleague, Christian Holm. Christian and I have been working side by side in the Layer7 management space for about 12 years. We previously worked at a previous company, then to Apida, before it was acquired by Boomi. And at that time, we and a few others made the move to DCOS to continue our work with Layer7. So, Christian, next slide. You're in control. There you go. Thank you, mate. So, for those who aren't familiar with DCOS, we're a German company based in Darmstadt with over 26 years of market expertise. There's about 75 employees, all very specialist in their own field. We provide services and products to some of the biggest companies in Europe, Middle East, and the USA. Here it only shows Europe, but we're spread further than that. We cover three core areas: infrastructure, management and automation, API management and integration, and software development. We have a solid, experienced team, which are mostly based in Germany, although a few of us, including Christian and myself, work remotely. We pride ourselves on the deep knowledge that we've built up together. You might also know us through our product. Christian, if you want to do the next slide, some of you might recognize this. Our DCOS API Gateway Manager, which is a specialist migration tool designed specifically for Layer7. And so today, Christian, next slide, please.
Yeah, you got the Gateway Manager up.
Yeah, okay. Okay, fair enough. Anyway, today Christian is going to share some very insightful information on best practices for policy development, service creation, etc. It's all about using frameworks and creating standardized, efficient Layer7 services. So I won't talk anymore. Just leaves me to pass the mic over to Christian and let him continue with his presentation. As we say, probably best not to put your questions in the chat, and we'll see if we can answer what we can afterwards. Christian.
Okay, thank you very much, Vince. So as Vince already mentioned, I've been a consultant with Layer7 Gateways for coming up on 13 years now, and I come from a software development background. And in those years, I've learned a lot, obviously, but also gathered some tips and tricks and best methods as I tried to solve problems through those years for clients. So today I want to go through the little tricks I've learned in terms of speeding up policy development, making it more streamlined. And I also created a sort of development framework, and I wanted to sort of show behind the curtains how I built that up in terms of methodologies that I used. So this is my take on trying to make the most robust development format. So these are some of the tricks. So for example, the compare these regular expressions. So we use the compare assertion a lot, obviously, and it's fantastic. It does what it says on the tin, but it has a lot of bounds checking and protection within it, and obviously because it's a very generic solution. But a lot of the times in your policy, you'll be checking, for example, status booleans, like is service enabled or is there a fatal error? And these are variables that you're defining yourself, so there's no ambiguity about its value. It is either true or false. And as you can see on the screen, regular expressions are in fact faster by quite a considerable percentage. And yes, we're talking very small amounts, but don't forget, we're talking about sometimes 20 to 30 of these compares in a mid-sized policy, and then in all of your policies. So it can add up very quickly and make quite a big difference on your processing time. Another thing I want to touch on is global variables. Some of these things, of course, I'm sure all of you already know, but I just want to highlight because these are the things I've come across at clients. So you can create global variables by defining service dot in the beginning, and these are then available throughout the scope of your execution run or your request run. So if you're in a encapsulated assertion or whatever, these are available. They do have a larger hit on processing than a normal defined variable, but it's a balancing act. So imagine the scenario: you have an encapsulated assertion and you have maybe 5 to 10 of these sort of status variables, or a message variable, for example, that I use that contains all of these service specifications. And if you were going to pass all of these through into an encapsulated assertion and pass them back in case of change, okay, fine. But then within your encapsulated assertion, you want to call another encapsulated assertion. Well, you've got to pass them all again. And underwater, the Java code must still iterate through this list and going in and coming out again. And then you start to hit a point where you think, oof, maybe it's time to use a global variable. There's one snag you can face, which is that little code snippet I've added. So if you want to access a global message variable within an encapsulated assertion, you can, it works fine. But the problem comes when you use standard assertions that need that message drop down you'll get. Because the policy manager itself doesn't know of the existence, because it's not literally defined in the code, I usually add one of these variable reference snippets. And as you can see, it's totally safe because the first thing it does is continue, so it breaks out of the loop. But it has defined it, so the policy manager now thinks it's a valid message variable, and suddenly you can use it in your dropdowns. So the next thing I want to touch on is encapsulated assertions. Going to clients, I've seen a myriad of usage of these things. I've seen some clients that never use encapsulated assertions, and they had, for example, the include policy fragments, which are great. But the problem is they, for example, had these very large, beautiful solutions in an include, but they then used it in 5 different places within their policy. And we are talking about a parser, not a compiler, which means that the gateway will include that huge block of code 5 times. So its final script before passing and executing will be a lot larger than you thought it would be. Once or twice, okay, but if all of your services start doing this, it can get rather big and can eat in the performance of your gateway. So I love the usage of encapsulated assertions, but I try to create generic solutions with them. So when I'm faced with a situation where I think, okay, this is encapsulated assertion time, I always try and take a step back and think, okay, I know how to solve this current problem, but how can I make this function basically that I'm creating, how can I make it more generic? What other kind of situations or services will want to use this, and in which way, to try and future-proof it a bit. Because as you can see at the bottom, the problem is that once you've created your encapsulated assertion with its input and outputs, and you've saved that and you have 600 services, you can't just quickly mix it up and change them, because as soon as you edit that service again, the underwater XML will invalidate its current values. So you can add parameters, but you can't remove or readjust. You have to be very careful with that. And it's a sneaky one, because you won't notice it until you actually save. And then you're going to start looking for, you won't understand why it's not working, and you'll start looking in the code you added. But actually, the problem will be that the nullified value is going into an encapsulated assertion somewhere. I'm sure all of you have had this sometime or other if you've been developing policies. I also try and maintain a lid on how many encapsulated assertions. So I have seen people use them literally for one service, and it only had one line of code in it or something, which kind of defeats the purpose of encapsulated assertions, because you can have way too many if you start doing things like that. And if you end up with 400 encapsulated assertions, you kind of lose the plot a bit of trying to find out what they all do. And it can create a very confusing environment again. And one more last thing I want to mention about encapsulated assertions is when you're defining a type Boolean, it's all very pretty. You get a little drop down, true or false. But the problem comes when this Boolean you want to dictate or pass through to your encapsulated assertion, you already have in a variable, because you can't do that. It's a drop down. So I tend to keep my Booleans as just simple string inputs, unless it comes maybe from a payload or something. I don't know. There are situations where it's okay, but I generally try not to, because also within an encapsulated assertion, okay, you've got this Boolean coming in as a string, true or false, but now I want to call maybe within that another encapsulated assertion, which is a drop down again. So then you have to if then else yourself around all of these potential variables, creating massive logic blocks that just aren't really needed. Another thing is caching. So I was surprised myself, but it kind of makes sense. The difference between Redis and using the local cache that comes with the gateway, as you can see on the screen, there's a large percentage difference. And it makes sense because when you're using local cache, that's all occurring within the same Java VM. So it's sharing resources. And then when you have a Docker or a hypervisor on top of that, that's going to start limiting that, of course. So you end up eating part of your own gateway's potential. And if you export that to a Redis, which runs in another memory segment, that makes a huge difference in speed. So a thing to note. When it comes to service structures, okay, I'm sure you've all got templates. I can get a bit obsessive compulsive. I like to just have one template and keep it simple and try and encapsulate everything I can within that. So I've add inline commenting. A lot of times I've looked at services and I get this screen full of flat code with comments like doing some checking here and things like that. And I understand it's working and fine. The problem is I'm Bob the Builder number 4, and in half a year, Bob the Builder number 5 is coming along, and he has to read it all again. And the first thing a compiler or a parser does is strip all the human rubbish out of it. So it has no impact, zero impact on execution. So I like to space it out, use the comments. It makes it a lot easier to read. And the same goes with the all assertion. It also has zero impact. The root of the policies itself is basically one big all assertion. And I'm not surprised if, for efficiency, the gateway underwater actually elevates all assertion blocks to its parent level and so forth, because it's really there just for us as developers to be able to make it raw readable. So I tend to use that a lot. If you have logical chunks of processing, then wrap it in an all assertion with a good comment behind it. And that way, when I open a service that I haven't used before, or a new developer comes, he straight away knows where he needs to be within that policy, because they're all sort of using the same philosophy. And to that end, I usually also create a snippet policy, which is like a bucket containing, for example, standard regular expressions for a true Boolean compare, or these sorts of things, because you ensure consistency by just copy pasting it. And I also do that for switch blocks. So that's things like this, at least, which is, in developer terms, basically a switch block with a very strict format of how you format the commenting and this sort of thing. Yes, a bit obsessive compulsive maybe, but it makes a huge difference when you need to read code repetitively, because if you have 600-700 services and you're jumping between all of them, if they all have this sort of structure, you start to read it a lot faster than some massive block of code where you literally have to start at line 1 again to figure out what's going on. Another thing I often see at clients is they haven't accounted for a global rate limit. Yeah, sometimes maybe a bit over the top, but I still find it worth the small hit of doing a rate limit test twice. So, of course, there are a lot of load balancers and systems before a gateway, usually. And if you get a DDoS attack, they will help to protect against that. But in some situations, it won't. And I find it safer to add a global rate limit first. So that's before you do anything else, is first test if you're getting hammered or not. And I just want to add that DDoS attacks aren't always malicious. Let's say I work for the company, and I'm from the internal network, and I'm building some Java code, and I'm not very good at the job, or I've made a stupid mistake, and I've got some sort of loop that's hitting the gateway the whole time. So, and then I go off because it's Friday afternoon, and I've left it running on my desktop PC. So these sorts of things can happen, and then you start getting a DDoS attack from inside. But it's not malicious, and most DDoS attack preventions are for incoming traffic. So this can happen. And then after that, obviously, you do your normal rate limiting. Another thing I find very important, which has helped a lot of clients down the road, is it's very important to have a service start and a service stop encapsulated assertion. Even if it's empty, it doesn't matter. Put it in. If it's empty, it has zero impact. It's purely an execution point to jump back and forth. But eventually, a request will come in where you need to adjust something, or can you add this logging temporarily, or whatever. It will save your bacon down the road somewhere when you need to do an adjustment that applies to all or a large segment of your 600 policies now, without having to edit them all. I try and avoid touching the global message received. The reason being is that every request goes through there, including RESTman, GraphMan, your monitoring tooling, everything goes through global message received. And this is a hit you don't really need, because any code you've got in there for your services doesn't really apply for RESTman and all these sorts of things. So I try and avoid it at all costs. Sometimes it's the perfect fix for a temporary solution, but usually it's best to avoid it. And as I said, things like this down the road, eventually the need will come to do something like this, even if you don't think so at the moment. My experience has taught me it always happens. And some other little things I do. So you have a service start, but I also have another start section, which is more global initialization encapsulated assertion. And that is because Booleans have, for example, a tri-state. So if I'm testing a Boolean using regular expressions, it can be true, false, or the variable doesn't exist. So if you're testing, for example, a Boolean on false, but the variable doesn't exist, it will fail. So you have to be careful the way you tackle that. And I always have a global segment for setting up variables. So, global variables and things like that, they need to be properly initialized to avoid those sorts of tri-state problems. And another thing I like to do is developer hooks, but they're not real developer hooks because it's not a compiler, so you can't dynamically link code. But what you can do is, one of those exceptions is to use the include. So I don't want to go too deep into this because you can talk for hours about it, but what I'd like to do, if you have more than one person, is if we take the global service entry point and you have, most APIs are grouped maybe by country or business unit or some sort of defining element that groups them. And for a certain group, you want to add some sort of new code or new functionality. Well, that's what the service entry point is for. Problem is that if they're all doing that, then you're all trying to edit that fragment all the time, and you end up with a very messy service entry point that's basically if then elsing itself to crazy. So then I try and create an include within each of these groupings that's then called, if valid, by the service entry point. And then you can have things like, if you do proper initialization in your service entry, where you have toggles or booleans to enable or disable the elements it's going to actually execute later on, through this begin hook, you can then turn them off or on depending on the situation for each of your groupings. So systems like that, they really help you sort of future-proof and adapt to changing needs without having to adjust your actual policies all the time. So now we get to a bit more different kind of things, and that's abstraction layers. Oh, it's a fancy name, but what I mean by this is all too often I've gone to a client and I completely understand you've got a shiny new gateway and you're making your first group of policies, and you have, for example, add audit statement assertion or add audit logs or whatever. And you're using that and it's logging, and that's, and well, it does what it says on the tin. We're all happy. Problem is that in 2 or 3 years, you've got 600-700 policies and they're all using that. And sooner or later, the fatal request comes in, we want to update our logging. And then you've got a problem. So with things like this, it's really important to create a buffer or a layer between the core assertions and your services, because that way there's only one place you need to adapt these sorts of things. So you can change your logging literally by just editing one file. Even if it just contains a simple add audit log, at least you've created that separation. And I like to then take it a step further, and I add something I call log attributes or groupings. So you give it a name. This is related to authentication, or it's a warning or service or whatever kind of groupings you want. And that way, as you can see in the example I've got, this is what my framework then returns, depending on how you've set it up. So it'll give you literally the logging elements you need at that moment. And this becomes much more beneficial, as I'll try and explain later on. Once you've got this layer, you can expand the logging. So you can create log scrubbers. You can have multiple destinations for different types of logs. So you can really advance it without having to worry about, again, changing all of your services or problems like that. This also applies to cache. It's the same thing. I like to do CRUD completeness, and what I mean by that is if you want to delete cache, normally that means well, we'll just create the cache again, but with 0 time. Yes, that works. Problem is, well, for me at least, the problem is 2 things. First, readability. So if I'm reading a policy and it's calling an assertion called delete cache, I get it. I know what it means. But if not, it's writing cache, and I'm like, what's it writing cache for? And I have to, open it up and look at the variables. Oh, it's okay. It's deleting the cache. So it just creates a much more smooth reading experience in your code. But more importantly, when you do a switch from local cache to, for example, Redis or Gemfire, then you're going to have a separate assertion for delete. And there you go. Now we've got a problem because you've never been doing that before. So it really makes it a lot more smooth. I think I had one client that that wanted to do the switch with from local cache to Redis, and it took me about 10 minutes. That was it, once they had Redis up and running, obviously. So that was a very quick switch. Another thing is it can help you with controlling the cache. So I've been developing in total for coming up on 40 years now, and maybe it's my blonde hair, but I still end up debugging and completely confused why my code isn't working, only to realize that I'm passing stale cache data. So it happens even after 40 years. With this kind of system in place, you can have aforementioned global variable where you can just say, look, debugger.disable cache, and it'll disable all the reads with a simple compare statement. And that way I always know I'm getting fresh data with my development or support. And it's good to have, as it says, a single pipeline when using technologies, because that way it's a lot easier to switch, and eventually things get changed and they need to be switched. I also always try and introduce a generic error terminator. So return templated response and all these sorts of things. I try and create this abstraction layer for that as well, with needed parameters that get passed to this encapsulated assertion. And that way you can switch partially. You have control again. Very important to get, I think, to get these sort of things in, because, protocols and APIs and these sort of technologies are always changing and adapting as time goes by. The next thing I find really important and have helped a lot of clients with is separating code and data. So there are usually two camps in this. On the one side, we've got people that literally put all of their values into the service itself, including backend URLs and the rate limit values and whitelisting and all this sort of stuff. We've got the other side, and they have 700 cluster-wide properties or something, and that also gets rather confusing. So especially when you need to start migrating and you've got a one-to-one mapping with your cluster-wide properties, you can sort of get a problem when you migrate. I mean, accidents happen. And I once had it at a client where the pre-prod cluster-wide properties were by accident migrated into prod. And of course, suddenly a lot of things stopped working. But theoretically, there's only one unique cluster-wide property that's needed, and that's the who am I. Once you have that, you can then create, well, resources, I call them, where one is, for example, an environment mapping, where you say your nodes, your clusters, and in which environments they sit. So with the first two items, you know who you are and you know where you sit. Once you have that, you can start to create all sorts of profiles. A service profile, like the example here, which will define all the elements of a service. You can create whitelisting profile, or whatever you want, error responses, log scrubber profiles, all this sort of stuff. Then, after that, you can start to create your tooling around it. So I built a CRUD storage system that can either talk to cluster-wide properties or JDBC or even Git. That's all possible, where it uses the above-mentioned resources to extrapolate what it needs for a running service. And that includes variable substitution, so you can put literal gateway variable names into these cluster-wide properties or resources, and it'll on the fly convert them into their live values. I use a two-tier caching system for these tools. So one stores the raw XML resource, including all of the different environment, cluster, and node values. And then for a specific service, the second layer of cache is, as you can see, a flattened JSON profile that literally just contains what's needed, because it knows which service it is, and it knows which environment it's in and which node it's on. So it can just take the data it actually needs for that run. And I keep these solutions very generic, so it comes with all sorts of manipulation tools. So you can merge two XML snippets, extract certain elements or sub-elements out of XML or JSON. And this just saves a lot of time, because the natural assertions that come with the gateway, they're brilliant, but every time I have to look up again, right, how did I do this again? Which variables does it need? How does it work? So I created a layer on top of that just to simplify the whole thing. And it's very beneficial. It saves a lot of development time having these sorts of toolings. So once you've got that in place, then you can start to have some fun with things like running modes. So if you think of a service running, and you've got your service profile that you've then taken out of your resources, that's great, but they are default and static by nature, and static in terms of they sit there and those are the values. Of course, you can change them yourself, but basically that's what it is. But I wanted a way to manipulate these things more on the fly. So I create what I call running modes, and these contain certain fields that can override or change the active state, the active running state. So think of the current logging, rate limits, whether the service is enabled or the node is enabled, all these sorts of things. And that really helps you real-time adjust what's going on, because they are dynamically assignable. You can assign them, as I said, to a service, a node, or a cluster, or just a service for a whole cluster. I mean, any scale of uniqueness you want. And you can define then, you can create the logic to define these fields in your service that are allowed to be overridden as well. So you can ensure that certain things don't change for certain services. And it's important to always have them time out, because this makes sure that any changes will always revert back to whatever the default profile state should be in normal execution. And at the bottom, I've just sort of a simplistic view of the hierarchical logic it'll use when trying to look up a field. So some of the examples that I've put into practice for clients. One is a turbo mode. So this was a client that had massive peaks, not little peaks, but massive peaks. If you think of a bank, they have payday at the end of the month. If you think of a sports shop, they have maybe certain races that are really big. Think of, I don't know, World Cup or you know, massive horse race. So they have enormous spikes. I mean, out of proportion spikes. Problem is, you don't want to have 90 gateways just lying around in the cupboard for that one day of the year. So I created a turbo mode that literally says, right, turn XYZ services off. They're secondary, they're not important. We just, in the next 2 hours, want to handle as many requests as possible, no matter what. We don't want to log anything. It doesn't matter if it fails, fail fast, get the next request coming in, keep the connections open. And this will then automatically revert back to normal execution mode after the 2-hour window you defined. Another example is disabling a node or a cluster. So you can define running modes that will set a disabled flag. This doesn't have any effect on the running of the services, but if you play a synchronization game with your load balancer, you can have a load balancer that periodically requests the current status or the current running mode, and if it sees that it's in a disable mode, it'll very cleanly take that node or cluster out of the pool. So when you see all the traffic is gone, then you can actually do a shutdown without having to, you know, forcibly terminate requests. And the final example, obviously, is, you know, if you're into problems, you want to try and find out what's going wrong, you can dynamically enhance the logging. And because you now have a tag system, you can say, okay, we want to enhance the logging, but we don't want to log everything. We just want to log anything to do with backend. So what's being sent to the backend, what's coming back from the backend, but we don't need to log anything about authorization or general service logic. So that way you can do that, and you can do that on a service or on a full node, whatever the scenario deems necessary. So let's start to put this all together. So if we built these sorts of things, these sorts of systems, we now have increased development by a large amount, a lot of adjustments made, like most requests I see coming in at a client are, can you adjust the rate limiting? Can you change the backend? Can you add this to the IP whitelisting? All these sorts of requests. And normally that requires a code change. Yes, it's a benign code change, but theoretically you've changed code, which means you should officially fire off all of your tests again and all this sort of stuff. But if it's just a configuration change, you know that the actual logic is still sound because that hasn't been touched. And it also makes it a lot quicker. And you can dynamically adjust what the nodes are actually doing in terms of your core code framework, but also what each service individually, how they are being executed. So this starts also allow more advanced features to be implemented. So I've created event triggers. So this one's very popular with my clients, and I get this working for them. So we all know we're all at work Monday to Friday and everything's fine, but then suddenly we all go off for the weekend, and that's when the problems start. And then we get called on Sunday and we rush behind our laptop and everything seems to be working again. And we've missed the opportunity to actually capture what went wrong. So then you get two things going. Yeah, we should log everything. And then you get the other side, yeah, we don't log everything because Splunk will cost us a fortune. So with this, what happens is, now that you've got your generic response error encapsulated assertion with error codes coming in, you can say, right, I'm going to create profiles. When error code X and Y occur, which means a backend error, then if that happens, let's say 5 times within 20 seconds, I want you to turn this and this and this logging on for this service, and I want you to do that for 5 minutes, and then I want you to go into a 4-hour cooldown period because we don't want to keep logging it. So this will help you capture problems, but keep your logging to an absolute minimum. And you can have multiple of these profiles running at the same time. So one for authentication problems and one for backend errors. On top of that, you can then start to think about backend failures. So you can do, if you have a backend failing and it's the backend is down, or there's the famous we got certificate problems. They're usually down for longer than a couple seconds, but this starts to eat up your gateway resources, because by the time the backend is called, this service has already checked authentication, checked rate limiting, and all these sorts of things, the standard security process. But what you can do is, with triggers, is then you can say, right, we're going to put this backend into a unavailable state for 30 seconds. So any requests coming in, they straight away get booted out again with the service temporarily unavailable, please try again later kind of message. So this helps you to fail fast and free up your open connections again to service other services running on your gateways. So all these sorts of things help to speed the whole thing along. You can then take this further, which you did, so you can create things like that help developers and support. So I created a set of sort of debug parameters you can send. So imagine you're in Postman and you're developing, or you're on a support ticket because a service is failing. If you're in the admin group or whitelisted, or however you set up your protection, you can now just ad hoc add parameters to your request. So for example, when I'm developing, I really don't care what the backend's returning for payload. It's not very interesting to me. What is interesting to me is what logs are being created. So here I can say, you know what, don't send me the payload as the response, just send me a list of the logs that were generated during this single execution. You can disable the cache, as I've already explained. You can set which log tags should be active just for this request. And you can enable things like profiling. So if you think of a multi-level code segment profiling, you can do, so not just groups of code, but within that, more groups of code, and it'll then log how long these groups each took. You can do things like endpoint injection. So this has been very handy for a lot of clients. So you can do things like the generic get Swagger or get Open API. So, and these sit outside of these definitions. So they're added whether the Open API spec allows it or not. But you can then add a protection around that in terms of whitelisting. So then you can start to create admin endpoints. So if you want to connect it to Jenkins and you want to have a status of all your services with specific information, you can then inject that in one go into all of your services. And you can do things like adaptive field changing. So imagine you have, I've seen it very often with clients, is they have services that, or systems that call the gateway, but what they do is they cache or queue a lot of the information that needs to be sent through to a backend, and then in the evenings, they get this massive push to empty the queue. But you can only assign a rate limit, and you can do a rate limit spread, but you can't say only between 3 o'clock at night and 5 o'clock in the morning. So you just have to give them a high rate limit that's basically valid 24/7. But with systems like this, you can then very easily say, okay, what are your requirements? Okay, so during the day, we're going to put you just on a normal 5 per second. And then from 2 o'clock till 4 o'clock, we'll give you, 30 per second, or whatever the case may be. So when you've got all of these sorts of fun features, it really helps you to organize your gateways and the services running on there, and increase the productivity enormously, because small, simple changes are literally a flick of a switch. And when you need to add new features, so I had, for one client, I had a whole division, a subdivision or business unit. Yeah, we want to change the whole response code system and the way it looks and the format and all this sort of stuff. And it was very easy to do, because I just needed to change part of the code, one of these generic abstraction layer assertions. And for their business unit, they had a whole different set of requests coming in. So it really made a big difference. So I created all of these things, and then I wrapped that with, of course, administration APIs around it that literally do it all for you. So you can even create a service. If you think about it, if you've got this sort of thing in place to create a service, all you need is a name and a service profile, and that's it. And so with that, you can basically create, if it's a simple proxy service, you're done. And if not, you've got a working template with a lot of the work already done. You just need to add that certain specific business logic that's needed for that service. So I built those, and then as you can see on the screen, it's very easy just to wrap a UI on top of that. So this is a UI I built that's hosted on the gateway itself that comes with the framework. And it just makes the whole thing a lot easier. But this is to emphasize how with these admin APIs or these systems, you can very easily use them in your own internal monitoring systems or administration systems that you use. It makes a big difference. So that was it. Those are the things I've created and the tricks I've learned with the clients I've worked for. I'm not sure if there are any questions, but I'm more than happy to answer any. I've tried to go through it as quick as I can, so hope it leaves enough time for questions if there are any.
There is one question, Christian, in the chat.
Yeah.
It says, I started using encapsulated assertions in a limited way once the debugger could actually dive inside them. I guess that's more of a comment.
Yeah, exactly. There's a checkbox when you create an encapsulated assertion, and if it's enabled, then you can trace through into encapsulated assertions.
One little caveat there is if you're using lots of encapsulated assertions and they're all massive, the debugger takes a long time to pull that stuff in.
Okay, so just to remind everybody, you can take yourself off mute now if you'd like to come off mute and ask a question, or if you prefer to type in the panel, you can do that as well.
If there are also sections, because I had to go through it quite quickly because there was quite a lot. If there are sections that you'd like a bit more explanation about, I'm more than glad to go back to that slide and explain it in more detail.
So we do have another question that came in the panel. It says, if you advise against using the message received, where do you put things like the global rate limit?
Yeah, well, that is where this service start comes in again, isn't it? Because that's that central injection place. So let me see if I can whiz back to my template, which was all in the beginning. If you see here, if I can get the right slide up, sorry. I'm not a presentation master at this software. Oh, here it is. This one. So if you see here, I use firstly this. So this is what I was talking about, a global initialization. Thing is, you've always got oddball services that won't be using this, maybe some FTP streaming service that just always sits out of the norm. But you still want to use certain basic logger assertions that you've created and things like that. That's why you have this. And in here, this is where first thing it does is the global rate limit. First thing I check. Most important, first thing you do. This is first important because otherwise I can't log it. So I need to do this first, and then it does this. So the first thing this will do is check global rate limiting, then set, as I talked about, generic toggle variables, Boolean variables. Then I'll call hooks if needed, and then I'll actually do the actual work for the service that's needed. So that's where I put the global rate limit. And then, as I said, later on in service start, it does the service rate limit or the normal rate limit. So that's where I put that. The point is to fail fast with the global because you're being hit, I don't know, 200 times a second, theoretically. So you need to stop it because it's bad. We don't want that. So,
thank you. This is Jackie Wilson. I'm going to ask the question. So one of the things that we have ran into before, speaking of fail fast, is that if it's put in the policy like this, it fails slower than if it was in the message received. And where we have this problem is on like number of connections that are supported by a gateway or a cluster.
yeah.
Yeah, the example you gave was perfect about not all DOS attacks are external. We've had that when we first installed the API gateway. We realized that we were getting hit by people in like these authentication loops. So it would go to their app, it would fail to come back and just bounce back and forth, and we were getting hammered.
Exactly.
We didn't know it.
Yeah, exactly. I know it.
But regardless, one of the problems we have is we run out of connections on the gateway for these DOS attacks, and so there's really, without something sitting in front of the API gateway, there's not much of a way to prevent that, because in order to detect that you've got a connection, they've already made the connection. So it's like a catch-22 kind of thing. And so that's the reason it was put in I put it in the message received, so it would never even call the policy. It would fail really fast. So, but I see the point you're making here about how it's in my case, it applies to everything going through the gateway, obviously, and you can't. Your FTP example is good, and it's going to go through the rate limit as well. So that's the reason I asked the question.
Yeah, no, completely makes sense.
In the global message received, you have to then decide which service it is that you're actually, doing that for and everything. So there's some more logic that goes on. Whereas if you do it in the service, the actual service that has been hit is the one that stops it quickly and leaves the other ones alone.
Yeah, exactly. DDoS attack is often service related because they're going to hit, 1, 2, or 3 maybe URLs. And if you rate limit just those services to protect against DDoS, then the other services will carry on functioning. But if you put it in the global message received without, of course, a logic block around it, then you're going to block the whole gateway from a DDoS. So, and that creates a hefty price again that they all have to go through. But I mean, there are just certain situations. Everything I've said is in general. There are always unique scenarios where, exactly. I mean, like as you said, if you're having a lot of problem with that, then maybe the global message received is the place to do it. I just try and philosophically stay away from it, because it is inherently something that will then, I mean, the thing is, when you use it once or twice and then, you've left and someone else comes along and carries on your work. Oh, he did that here. Well, I'll do that as well. And then before you know it, you've got a global message received full of code. And it's that kind of thing I'm always worried about, because, my job is I come in after I'm Bob the Builder 5, and after me is going to be another whole row of Bob the Builders. So I always try and leave it in a state that's protected as much as I can. That's kind of my philosophy. But there are always unique situations, of course. So I completely understand, and thanks for the question.
Yeah, hi, it's Dave here. So we don't really use rate limiting as any kind of protection against DDoS attacks. I guess that there are requests that come through via the gateway. And for us, it's more about protecting the back end, because the gateway is not the only channel. So if the channel via the gateway gets overloaded with DDoS, then the other channels, the desktop or whatever, can still function. In the end, we sort of moved away from trying to implement DDoS protection on the gateway, and we implemented Akamai Prolexic instead. And that's a far more comprehensive solution that sits out there in front of the API gateway. I'd be interested, Christian, your thoughts on the use of circuit breakers. You haven't sort of mentioned that so far. It looks like you'd almost created a custom circuit breaker earlier on in the presentation, but that's actually now sort of built into the gateway.
Yeah, no, it is, yeah. But this kind of thing started before the circuit breaker was introduced.
Yeah,
so I'd already sort of
9 or 10 years ago, this was created. So the circuit breaker type.
Yeah, the certain building blocks. But definitely, I mean, circuit breaker is a brilliant assertion. And it does what it says on the tin. So definitely, yeah, it's definitely a great thing to use. I'm just showing you certain solutions that I built that are still completely downwards compatible, kind of thing.
Yeah, no, I've used a circuit breaker. It's worked well for me.
Yeah, that's very useful.
We have had another question come in through the chat, Christian. It says service level rate limiting What is the reason having the rate limit after whitelisting authorization and not before the whitelisting authorization?
Well, that kind of depends on if you're rate limiting on IPs, for example. You want to try and first make sure. So the thing with whitelisting is if it's not allowed, if it's an IP that's not allowed, you don't want to, for example, tell it that it's hit a rate limit, or that it's an invalid rate limit, or any kind of rate limit information. The most important thing is to give as least amount of information as possible when returning problems, but you do want to tell people certain problems. So I tend to put rate limiting after whitelisting, if possible, depending on the situation, because then I know who's coming in is a valid input or a valid IP, as it were, and then I'll apply rate limiting. It depends how you're doing your rate limiting. If you're rate limiting on client user, then you need to do authentication first, otherwise you don't know who it is. But if you're doing it on client IPs, then you first want to make sure it's a valid IP before you start rate limiting them. That's the philosophy behind it, anyway. I don't know if that answers the question, but that's kind of the way I see it.
Okay, I'm not seeing any other questions come in through the panel. We can give it a minute. While we're waiting, I do want to let everyone know this, of course, is being recorded and will be available on the YouTube channel. So I'm going to be sent in the chat, in case you don't have it, a link to the Layer7 YouTube channel that you can subscribe to. And there is a list of really all our office hour recordings can be found there. So we'll give it another minute, see if you guys have any other questions.
It's unusual because I'm not asking questions today.
That's what's missing.
That's what's
That's why
missing.
it's quiet.
Exactly, it's
You're
quiet
usually
because I closed my mouth after my first little bit of the meeting.
That's all it was.
It's an interesting session. Thanks, Vince, and thanks, Christian.
Yeah, excellent session.
More than welcome.
Christian was the one that did it.
Learning for many people. Good job.
Jackie, if you need to be able to talk about concurrent connections and things, I know a lot about that. If you need to know any more.
Yeah, I'll take you up on that, Vince. Thanks a lot.
No problems.
And I can if anyone wants the presentation, please just ask, and then we'll send it through as a sort of maybe reference, or what did that crazy Christian talk about? Please just ask.
Or a further one-to-one demo. Christian, I've seen this in a lot more detail than what we've seen today, including a full demonstration and everything. So that might be good for some people that want to see it.
It shows the potential.
Presentation. That'd be good. Thanks.
Yeah.
All right. If we don't have any other questions, we can close it for today. And thank you very much, Christian and Vince. Thanks.
More than welcome.
Good to see you all.
Yeah.
Take care.
All right. Thanks, everyone. Bye-bye.
Thank you. Bye.